All right, I'm going to go ahead and get started here with this math session. My name is Mrs. Russell, and I am one of the math teachers here at Graduation Alliance. Some of you might have April as your math teacher, but glad to have everyone here. I see there's only a couple people here, but we will, looks like my screen isn't showing anymore. Oh, do you guys see my screen? My iPad screen, it says welcome to my math session.
Yeah, it's there.
Okay. Angela, can you hear me? I see it's only showing your video. I don't see that your microphone's on, so that's why I was wondering. But anyway, I'm going to go ahead and get started. So today I'm going to be talking about slope. So what exactly is slope? So slope, there's a couple different ways that we can think of slope. So one of the first definitions is slope is an average rate of change. So what that means is basically how fast something changes over time. So if you look at these two lines, you can see that this line here on the left is steeper than the line here on the right. So that means that the line on the left is changing faster as time passes by. So in order to calculate slope, we can use a couple of different definitions. So the first definition that we're going to talk about is slope as rise over run. So what does that mean? Well, if you look here, we have a graph, 2 points. We have -3, -1, and 3, 2. And we want to calculate the slope between these 2 points. So in order to do that, if we use the definition of rise over run, we're going to start at our left-hand point, which is at -3, 1, and we want to see how we're going to get to this other point. So do we have to go up or down? Well, obviously we have to go up, so you're going to count how many. 1, 2, 3. So we go up 3. So since we're going up, that means our rise is 3. And then our run is how many do we have to go over? So it looks like we have to go to the right 1, 2, 3, 4, 5, 6. So we went up 3 to the right 6. So the run would be 6. So our slope is 3 over 6. And we always want to reduce or put in the lowest terms. So 3/6 we could reduce to 1/2. So the slope of that line is 1/2. All right, so we're going to do another example. So again, we're going to use that definition of rise over run. So notice here I have this point, this left-hand point, and then this right-hand point, and I want to know what's the slope to get from one point to the other. So using our definition of rise over run, we're going to start at this left-hand point, and are we going to go up or down? Well, we have to go down. So now we're going to count how many down. 1, 2, 3, 4, 5, 6, 7. And since we're going down, that's going to be a negative because up is positive, down is negative. So we're going down 7. So our rise is down 7 or -7. And our run, we're going to the right. So that's going to be positive. 1, 2, 3, 4, 5, 6, 7. So right 7 is +7. And again, -7 over 7, we can reduce to -1. So our slope of that line is -1, or you could put it as -1 over 1. All right, in this example, notice these 2 points are straight across from each other. So it makes a horizontal line. So again, if we were going to use our definition of rise over run, we start at this left-hand point and we're going to rise. Well, we don't have to go up or down at all. So then that would mean our rise is 0. And our run is 1, 2, 3, 4, 5. So 0 over 5 would reduce to 0. So any line that is horizontal is always going to have a slope of 0. Hi, Melinda, can you hear me? We're just going over slope, talking about slope as rise over run. And then the last type of line we're going to look at is a vertical line. So rise over run. We're going to start, you could start at either point. I'm going to start at this bottom one and go to the top. So we're going to rise 1, 2, 3, 4, 5, 6. And we're going to run. We don't have to move left or right. So we're going to run 0. Now, if you look at this, we have 6 over 0. So thinking about your division rules, can you ever divide by 0? No, you can't. So we say, since you can't divide by 0, we say that the slope of any vertical line is undefined. It has undefined slope. And you could think of it like as a cliff. If you were going to ski, you'd fall right off. So think of any vertical line has undefined slope. All right, so are there any questions on using slope or using rise over run to define slope? Okay, so then the next definition we're going to look at slope is a formula, which a lot of you probably have seen this formula. Slope equals y2 minus y1 over x2 minus x1. And these 2's and these 1's, they don't do anything really. Basically, it just means whatever y point you start with, that you have to use that same x coordinate. So let's look at this example to see what I mean. So if we have the point -4, 8, and 2, -5, and we want to find the slope using our formula. Well, the first thing we want to do is remember what one is x and which one is y. So in this ordered pair, -4, 8, -4 is x, 8 is y. And then in the second one, the 2 would be x, and the -5 would be y. So we get to pick which point you want to start with. Doesn't matter, you can pick either one. So let's say I'm going to start with this one. So using our formula, it says y2. Well, basically what that means is pick the y value out of that point. So out of -4, 8, which one's the y value? So 8 is the y value minus, and then we're going to go into the other point. So now we're going to look at this point and we want to pick the y value out of there. So 2 or -5, which one's the y value? -5. So what the y2 and the x2 mean, so see how I started with this y on top? That means I have to start with this x on the bottom. So I'd have -4 minus the x value from the other point, 2. Hi, Johnny.
Hi.
We're just talking here about slope. Glad you could join us.
Thank you.
All right, so we have, and this 8 minus -5 is 13, and -4 minus 2 is -6. Does 13 over -6 reduce? No. I mean, it could be a mixed number, but we want to leave it as rise over run. So we're going to leave it as 13 over -6, and that would be our slope.
I have a question.
All right. Yes.
So you said that it doesn't matter, even though it's labeled like Y2 and Y1, it doesn't matter if I use the first set of ordered pairs before the second one?
No.
It's just a consistency thing?
So we could, we could do it the other way just to see. So let's start with this ordered pair. So if we picked our y -5 minus our y in the other one, which is 8, and then 2 minus -4. So we have -5 minus 8 is -13, and 2 minus -4 is 6. So we really get the same thing. You get 13 over -6 or -13 over 6, which those are equivalent. The negative can be in the top or the bottom.
Cool.
So yeah,
Thank you.
Use either order pair, but it's just important that whatever one you start with on top, you start with that one on the bottom.
That's good to know.
Yep. Any other questions? All right, so here is another example. We'll do one more together, then I'm going to have you try one on your own. So here's our ordered pair, 4, 6, and negative 3, 9, and we want to find the slope. So pick which one you want to start with. So let's all agree to start with this one. So can anyone tell me what is the y value out of the pair 4, 6? Anyone want to
Is that a
jump in and
1?
tell me?
Would that be a 1?
It's a 4, 6. So what's the y value out of these two? 4 or 6? Remember,
Okay,
it
is
goes
that like a 4 times 3 or is that at 4 4s?
where are you looking?
Okay, I see where you have the 4 down there underneath there, but are we looking at the Y2 and 1 or what?
That's the formula. So we're using this. This is the formula.
Okay.
So now we're looking at the point 4, 6. So we have 2 points, 4, 6, and negative 3, 9. And we want to find the slope between those 2 points. So what we do is we're going to pick out of this ordered pair 4, 6, which one is y? The 4 or the 6?
The 6, isn't it?
Yes, good. So we have 6 minus, so we're using this formula, and now we want to get the y value out of this one. So out of negative 3 and 9, which one's y?
3, isn't it? Minus 3?
Nope. Remember which one is, it goes xy, just like the alphabet, W, X, Y.
Okay.
So which one's y?
9.
Good. So we have 6 minus 9, and now we want to go to the x value. So we're going to go back to this point we started with over here. Which one's x?
4.
4 minus, and then we go to the second point, and which one's x?
6. Oh, 3. I'm sorry.
Yeah, and it's a negative 3, but good. So we have 6 minus 9 is negative 3, and 4 minus negative 3 is positive 7. Negative 3 sevenths doesn't reduce, so that would be our slope of that line. Between those 2 points would be negative 3 sevenths.
See, some of those I can get, some of them I cannot get.
Yeah? Well, let's try another one. So once you do a few, hopefully it becomes easier. So I'm just going to write the formula. And after I get used to it, I keep out the Y2 and the Y1 just because that can get confusing. So if this is our point, what's the Y value out of 4 and 6?
6.
6, good. Minus the Y value out of negative 2 and negative 3.
2.
So
No,
Y. So remember, it
that'd
goes
be
X,
minus
Y.
3, right?
Yeah, very good. And then we go back to the first point, and now we do the X. So X is 4
4.
minus, and then what's the X in this second point?
2.
Negative 2. Good. So 6 minus negative 3 is 9. 4 minus negative 2 is 6. And then notice we can reduce that because what number goes into 9 and 6?
3.
3. How many times is 3 going to 9?
2. No, 3 into 9, 3.
Yep. And how many times into 6?
2.
Good. So that would be your slope. 3 over 2.
See, some of that I can get, but some I have just a problem with it.
Where do you have an issue? What part of it?
I want to try to do it like a fraction, and I know I can't.
Okay. Yeah.
That's what I try to do.
Right. So once you get it as it's in a fraction form, Leave it as like two numbers. Like a number over a number.
See, I mean, I went to school before and I'm 61 and I've never had to do algebra before.
Oh, yeah. Well, good you're learning it now. All right. So I'm going to open up the floor then for any questions that you have about something that you're working on. Hi, Deborah. So do any of you have any questions on anything? It doesn't have to be slope. It can be anything that you're working on in your math class right now.
It's just, to me, it's just about everything.
Mm-hmm. So what is it in your section right now that you're working on?
I think I'm working in algebra 2, I think.
Oh, okay. So you took algebra 1 already?
Yeah.
Okay. So anything in there that you need help with?
About everything, because I'm not doing something wrong. I'm not doing it right.
Okay. Is there a problem you want to show me I could work through with you?
Okay, let's see. Because I try to keep everything down that I've got, for the questions.
Right. That's good to keep a good notebook.
Okay. Okay, it's like adding and subtracting your ratio numbers.
Okay.
Like, I think 3 over 11 minus 8 over 11.
Okay.
Okay, that's the one that I've got. That some of those I don't understand.
Okay. So you have a fractions. So when you're
Yes.
adding and subtracting fractions.
Mm-hmm.
Okay. So when you add and subtract fractions, you have to have the same denominator, which is the bottom. So see how here they're both 11?
Right.
So that means you're good to go. So then you just subtract the top. So 3 minus 8.
So are they going backwards with the 8 minus 3, which is a 5?
Yep, but you got to go in the order. So since it's
Oh,
3
okay.
minus 8, it'd be negative 5.
See, that's where I mess up. I want to go backwards.
Yeah, you want to go the other way?
Right.
And then the bottom just stays as it is. So it'd be 11. So it'd be negative 5/11. And actually, my next part of this is going to be about adding and subtracting positive and negative numbers. So that'll probably be good for you.
Okay.
So we're going to talk about what do you do when you add and subtract positive and negatives? Because some people, that's confusing.
Boy, on that, wouldn't you, if you do that, like say, okay, there's another one, which is 1/5. It's 111, and it's a plus 511, okay?
Yep.
So what I don't understand is how they came up with the minus 411.
Minus 4?
Yeah, that's
Is
the
this
answer. The answer probably.
Is there a plus in there or minus?
Yes. No, it's got 111 plus 511.
So that should be 6/11.
Okay. See, that's where I messed up. I have a minus 411. See? I'm not doing it right.
Well, you must have subtracted there. 1 minus 5.
Okay. All right.
Angela, do you have any questions?
Hey.
Hello? So the floor is open for anyone that has questions about anything you're working on in math. If no one has any questions, then I'm gonna talk about basically adding, subtracting, multiplying, dividing positive and negative numbers. So this is a skill that you're probably, by the time you should get to algebra, they probably expect that you know it, but it can be tricky. So that's why I just want to review it. So we're going to start with a simple, I'm just adding numbers. And what I'm going to do is I'm going to use a number line just so you can kind of get the idea of visual representation of what are we really doing when we're adding and subtracting. So 3 plus 4, a lot of you probably know, well, that's 7. But using a number line, if we think of this point here as 0, we're going to plot 3. So notice 1, 2, 3. And then from there, we're going to add 4. So anytime you're adding positive numbers, you're going to go to the right. So 1, 2, 3, 4. And notice where we end up at 7. So 3 plus 4, 7. So when you add two positives, add them together and you get a positive. All right, and now when we subtract, so same thing, 8 minus 2, a lot of you probably know, well, that's 6. But just to see the visual representation, if this is 0, and we go to 8, 1, 2, 3, 4, 5, 6, 7, 8. If we're taking away 2, anytime we're taking away, we move to the left. So if you're adding, you go to the right. Taking away, you go to the left. So we're taking away 2, so we're going to go left, 1, 2. So we started at 8, we ended at 6. So now that idea of using a number line can be helpful when we're going to talk about negatives, adding, subtracting, positive, and negatives. So if we have -8, we're going to plot -8. So remember, negative numbers are always below 0. So 1, 2, 3, 4, 5, 6, 7, -8. And we want to add -2 more. So another way to think of as adding -2, that's the same as doing what? So those are equivalent. Plus a -2 or -2 are the same thing. So remember, if we're going to -2, do we move left or right? So anytime you're minusing, you go to the left. So if we're at -8 and we go to left 2, we're going to be at -10. So -8 plus -2 is -10. All right, -10 plus 5. So again, we're going to plot -10. So here's our 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, -10. Now we're adding a positive 5. So we're going to move left or to the right?
Right.
Good. So we got 1, 2, 3, 4, 5. So where we end up at is -5. So -10 plus 5 is a negative. You still have -5.
That's easier using that line.
Yeah, a lot of people like that because you can visually see it. Okay, so now -8 minus 3. So again, here's 0. So let's plot -8. 1, 2, 3, 4, 5, 6, 7, -8. We're minusing 3. So we're going to go left or right?
Right. Now you go
So
left.
if we're adding, we go what way? So if you're adding, you go to the right. If you're subtracting, you go
To the left.
to the left. So if you're at -8, -9, -10, -11. Okay, now -7 minus -3. So minus a negative, we don't like to see that. So what can we change that to? You remember?
Is it the plus?
Yes, good. Anytime you have two negatives and you're minusing a negative, you can put them together and make it a plus of 3. So these are equivalent. -7 minus -3 is the same as -7 plus 3. So if we plot our -7, and now we're adding 3. So adding, are we going to go right or left?
Left.
Adding.
Then we go to the left if we're adding.
So think of
we
it,
got
if
a
you're,
minus. We got a minus though, don't we?
we're adding, right? We got a plus 3. So anytime, so if you're adding, you're going to the right. So I mean, you might want to write this down. If you're subtracting, you're going to the left.
I did it wrong. Okay.
And these is if they're positive numbers. So we can always make them a positive number by either making it a plus or a minus. So if we're adding 3, we're going to go right 3. So we would end up at -4. All right, so let's do a couple practice. So 3 plus -2. So we get, what's that? We could rewrite that as 3, what? Instead of plus negative, could we have, that's the same as just a -2? So what's 3 minus 2?
1.
Yep. So we'd be at, so if here's 0, we're at 3. If we're minusing, do we go left or right?
You go left. I mean
Good.
right.
So we're going
right.
left. No, you were right.
Oh, left?
Left.
Okay.
Left. And so you end at 1. So you were right. 3 minus 2 is 1. Or 3 plus -2 is 1.
I'll get this sooner or later.
Yeah. The more you practice, the better you get. Okay. So here we have -3 minus -4. So anytime you see a minus a negative, we don't like that. So we're going to change it to plus a positive, because this is easier to work with. So if you have -3, and now we have +4. So if it's a plus, which way are we moving?
Right.
Good. See, you're getting it. So right 4, 1, 2, 3, 4. So we would end up at 1. So a -3 plus 4 is a positive 1. So that's adding and subtracting. The other thing you might have to do is multiply and divide. So here I just wrote some rules. If you have a positive number times a positive number, that answer is always going to be what? Positive or negative?
Negative.
Positive. If you have a negative number times a negative number, that answer is always going to be?
Positive, isn't it?
Yep. And then if you have a positive number times a negative number, that's going to be?
Negative.
Mm-hmm. And a negative times a positive, same thing. And then the same thing's true if you're dividing. If you're dividing a positive number by a positive number, you get a positive number. If you divide a negative number by a negative number, you get a positive number. A positive number divided by negative, you'll get negative. And negative divided by positive, you get negative. So those ones, pretty basic. Only one. So if we look at an example here. So a 6 times 3. So we have a positive number times a positive. So we know it's going to be
18.
Yep, positive 18. Negative 6 times negative 3. So a negative times a negative. So it's going to be
-3 or -18.
so a negative times a negative.
Negative times a negative. We just had that.
Yeah.
Isn't that, it's a addition, right?
No, is it
No.
going to come out to be positive or negative number?
Okay, it's gonna be, wouldn't it be a
Well, let's go-
positive?
Yeah, let's go back to that slide we just did.
Right,
This one. So a
Okay.
negative times a negative always comes out to be positive.
right, okay.
So that would be a positive 18. And then we have a positive 6 times a negative. So anytime you have a positive times a negative, it comes out to be,
Negative,
yep. And then a negative times a positive, same thing. All right, so then the same as if we did division. So let's say we had 9 divided by 3 is what?
3, right?
Yep. Negative 9 divided by negative 3 would be what?
+3.
Yep. And then negative 9 over positive 3 would be,
It'd be -3.
yes, good job. And then 9 over negative 3 would be -3.
3, negative, same thing, -3.
Yep.
I better shut up so somebody else can answer.
You're doing good. Angela, I don't know, maybe she's on mute or something because I've reached out to her a couple times, but see her in the video, but that's about it. All right, well, that's all I had planned for my session, but I'm here to answer any questions you guys have. So
I'm just, maybe I can go forward now and do those lines. That seemed like it was pretty good.
well, good. Glad that you found that helpful.
And I'm glad I got to make it in the class.
Yeah, it's nice that you could find the time to do it.
Does equations work the same way as what we just got done doing?
Like solving equations?
Yes.
Well, we can do a couple of those if you want. Like, are you talking about like 3x plus 5
Yes.
equal like 17?
Mm-hmm.
Yeah, so here, when you want to solve for an equation, you want to get x all by itself. So what you have to do is you have to undo everything that's hanging out on the side that X is. So we want to, first thing you always want to look for, is there anything added or subtracted? So see how we have this +5 on the side where the X is?
Mm-hmm. Yes.
We want to get rid of that 5. We want to get it out of there. So what's the opposite of add?
Subtract.
So we're going to take away 5. And whatever you do on one side of, so sometimes people will put a line here, because whatever you do on the left side, you have to do on the right to keep it balanced. So we have 3x. Nothing happened there, so we just bring it down. But then we have +5 minus 5. So those cancel each other out.
Did I just lose you?
Yeah, my iPad, I think. Well, there, I think I'm coming back. Do you see my screen or no?
No, I still see follow instructions below for an iPad.
Okay.
Arlo. No. Woo!
Oh, I don't know what I'm doing here.
Do you want to drink water?
Yeah, now's a good time for a water break, right?
Yes. I'm babysit for the 2-year-old.
All right, I think I'm coming back maybe.
Oh, there's your background. Beautiful boys.
Thanks.
Oh, those are your babies?
Yeah, well,
They're
I
cute.
have 5 now. That was a couple years ago. Okay, here we are.
Put those in the oven. In the oven.
All right, so we have, are you back here, Johnny?
Yeah, I still see your kids.
Oh, you do?
Yes. You got them
I see.
sideways now.
Uh,
Is this what the chocolate frosting was meant for? Or that's cornbread.
you see a whiteboard yet?
I see it up in the corner. We have 3 times plus 5 equals 17. Nope, I just see a whiteboard now.
Okay, good. So we were solving this for X.
Yes.
So we had the +5, and we wanted to get rid of it. So the opposite of plus was subtract 5. And then we said whatever you do on one side of the equals, you have to do on the other. So we bring down the 3x. +5 minus 5, that's 0. So those cancel each other out. 17 minus 5 is 12.
Get him.
So now we're down to 3x equals 12. So we have 3 times x equals 12. So we have times. What's the opposite of times?
Division.
Division. So we're going to divide by 3. Whatever we do on one side, we have to do on the other. 3 divided by 3 is just 1. So we have 1x, which is the same as just x. And then 12 divided by 3 is 4. So we solve this, x equals 4. Because if you plug that back in up here for x, if x is 4, we have 3 times 4 is 12, plus 5 is 17. So that's what x has to be to make that true. So when you're
Okay.
solving equations, you're undoing everything. So you have to do the opposite.
Okay. This was really helpful today.
Well, good. I know April does them every week on, I think, April Barton's the other math teacher. She does them every week. So hopefully you can make her sessions too.
Yes. Because, like I said, some I can get, some I can't.
Right. Some is just easier to walk through it with the teacher.
And then it says to retake, so I try to retake, and then it seems like I go lower than what I had.
Yeah, so anytime I would you could write some of those problems down and then we could help work you through some examples that are similar.
Okay.
Yeah, I'll hop in for a sec, Joni. I just checked the schedule, and April's session is on Thursday at 2:30 your time. And I sent out those reminders, so I'll send you an invitation for that one.
Okay,
So,
thank you.
yeah, bring some notes and those questions, and she'll definitely be able to help you out too.
Okay.
Janae's amazing, so lots of support.
Yes.
So is there anything else you want to go over, Johnny or Angela?
Nope, that's about it.
All right, well, thanks for coming in, and hopefully you can make April's session, and then my next session, they'll post when that is.
Okay, well, thank you very much.
Thanks for coming, and have a great day.
Thank you,
You
Janae.
too.